This FRQ 2017, number 5, was made by Justine and Ananya from last year. So thank you guys. So hopefully you've tried this question if you're watching the video, but basically you're given two functions, one for particle p, which is the position, and the other one is for particle q, which is the velocity. They also give you the initial position of particle q. It's 5 at time 0. So in part A, they want to know when the particle is moving left. So something moves left if its velocity is negative, and it moves right if the velocity is positive. So your instinct, hopefully, was to find the derivative. The derivative, don't forget the chain rule. So you would do 1 over t squared minus 2t plus 10, and then multiply by 2t minus 2 because of the chain rule. Now, if you try to factor the denominator, it does not factor. And if you tried to use quadratic formula, you'd find that you would just get imaginary answers. And that's because it ends up being that it's always positive no matter what time. So only the numerator is going to matter here. And the numerator is 0 at 1. So that's our only critical point. Then you can make a sign chart. And when you do that, you want to limit your sign chart from 0 to 8 because the function is defined only from 0 to 8. And then test something between 0 and 1 and 1 to 8 in here. So you get a negative here and then a positive in this region. So as I mentioned, it moves left when the velocity is negative. So that means between 0 and 1. 0 is inclusive because it's an endpoint, and so it's moving at that point. And 1 is not because at 1, the velocity is 0. So it's not moving left. You got 2 points for this part of the problem, 1 for finding the derivative correctly, and 1 for your answer for your interval. In part B, you're trying to find all the times where the particles travel in the same direction. So this is kind of similar to the last part. You need to use the same sign chart you had just created. But you also want to create a sign chart for particle Q. So factor this, and it factors in a t minus 3, t minus 5. So there's 2 critical points, 3 and 5. And then just plug in values to here to get your sign chart. So it's plus, minus, plus. Now, the students wrote the sign charts this way, where they made them like very accurate, like more like a number line, because that way they can compare and align to see when they're moving in the same direction. So this is negative here, but you can see the particle Q is positive. So those are opposite directions. We want them to be going the same way. In here, from 1 to 3, you can see that they're both positive. From 3 to 5, they're opposite again. And then from 5 to 8, they're both positive. So the intervals are going to be 1 to 3 and 5 to 8. You're going to include 8 because it is an endpoint that is included. You get 1 point for your intervals, and you get 1 point for this sign analysis where you're comparing. It looks like you get 1 out of 2 points if only one interval is correct. So if you only wrote this one or you only wrote this one, and then you don't get any points at all if you don't have any analysis. So if you're not kind of explaining where your interval came from and you just wrote the answers, you would not get points. All right, in part C, find the acceleration of particle Q, and then is it the speed increasing, decreasing, or neither. So to find the acceleration, you just want to take the derivative of the velocity. So that's 2t minus 8. Then plug in 2 to get the acceleration. Now the acceleration is negative, but in order to tell if this particle is speeding up or slowing down or neither, you need to also find the velocity at 2. And then you compare the signs. So because this acceleration is negative and the velocity is positive, they're opposite signs. So that means that the speed of the particle is decreasing, or you can say it's slowing down. You get 1 point for finding the acceleration, and then you get 1 point for saying that the speed is decreasing, and because they have opposite signs. And then in the last part, find the position of the particle, and then the first time it changes direction. So in order to get from velocity to position, you want to take the integral. Now, if you do the integral of velocity, it gives you displacement. Remember that you need to add the initial value in order to find the position. So that's what this is here for. They gave us this initial value in the directions. They said it was 5. And then here we're just going to do the antiderivative of the velocity. So that's this, and then plug in the bounds, and you get 23. So you get 1 point for finding the antiderivative right here. You get 1 point for using the initial condition of 5, and then you get 1 point for this answer. And sorry, the question says the first time it changes directions, and that's why we're finding it at t equals 3. Because from our sign chart earlier, we knew it changed directions at 3 and 5. So that was it. Thank you, guys.